Welcome to Investigation 2.3. In this investigation, we are going to be factoring quadratic expressions. So our focus question for this investigation is, what is the method for factoring expressions, that's a new word, as a product of two or more factors? This is related to, and how is this related to the distributive property? So to refresh ourselves, a factor is essentially parts of a number that are multiplied. So if we're looking at 10, the factors of 10 are 1 times 10 and 2 and 5. So 1, 2, 5, and 10 are all factors of 10. They're numbers that break down 10 and multiply by each other to become 10. In this case, we're going to be looking at the same sort of concept, but instead of looking at a simple number like 10, we're going to be looking at numbers like this. X squared plus 8x plus, let's think, times 6, or plus 16. So looking at this, I could break this down into two factors, and those factors are going to look like binomials. They'll look like x plus 4 times x plus 4. So we learned in investigation 2.2 that we can take this information and we can turn it into this information, x squared plus 8x plus 16. But what we can also do is we can take this information and turn it into x plus 4 times x plus 4. So kind of fun. Let's go and get a couple of words worth knowing. Our very first word worth knowing is binomial. Whoops, sorry guys. Binomial. And our book defines it as an algebraic expression that is the sum or difference of two terms. For example, this is a binomial, x plus 3. This is also a binomial, x minus 4. And if we wanted to, we could have two binomials in one expression, and we could potentially have it be x plus 3 times x minus 4. And that's getting into the form where we know these two binomials will multiply to be a quadratic expression. And that's kind of exciting. How exciting. Aren't you thrilled? So please get that definition, an algebraic expression that is the sum or difference of two terms, and have these two examples here for you in your words worth knowing. Our next word worth knowing is factoring. Factoring is the process where we take something like this, x squared plus 8x plus 16, and turn it into two binomials of x plus 4 times x plus 4. So factoring is the process. I'm going to type this out, math magic, just one moment. All right, so it is the process of turning the expanded form of a quadratic equation into two binomials. So it's going from this to this. And we're going to learn how to do that. So what the book provides you with is this. They said this girl, Lydia, noticed these things. She said, well, when we have a square binomial, so x plus 3 squared, or we could rewrite that as x plus 3 times x plus 3, when I have a situation like that, I find that the expanded form has three terms. So we'd have the term x squared, the term 6x, and the last term of 9. So we have three terms. She says that, number one, the first term is the square of the first term of the huge binomial. And in all reality, I'm going to take out the word huge because I don't like that word, of the binomial. So we essentially have the first term, x times x, or squaring it, x squared. That's what she says. It's the square of the first term in the binomial. X was the first term, and we're going to square it. She then says the second term, or 6x, is twice the product of the two terms in the binomial. So we see x and 3 in our original binomial, and we are going to multiply it times 2. So we have x times 3, or 3x, and 3x times 2 would get us 6x, and that gives us our middle term. Then she also states that the third term is the square of the second term in the binomial. So our second term in the binomial was the 3. So we're going to take that 3 and times it by itself, or square it. So we have 3 squared, or 9. So she sees like a little pattern here. So we're going to go through that same pattern with a couple of problems. And we're going to go from the factored form and see if we can find, or the expanded form, and see if we can move back into the factored form. So let's see if we can do that. Have a little bit of Lydia's suggestions, and we're going to break this thing down. So we have the expanded form of x squared plus 18x plus 81, and it said the expanded form of the binomial has 3 terms. So we have 1, 2, 3. The first term of this the first term is the square of the first term of the huge binomial. So if we look at our initial binomial, essentially what we're going to do is we're going to be turning this thing, our x squared plus 18x plus 81, and we are going to turn that into an x plus something times an x plus something, and see if we can find the exact situation that it goes back to. So the first term, she says, is the square of the first term of the binomial. So we have x squared. So our first term is x times x. So we could say that in our binomial, the first term was just simply x. The second term, she says, is twice the product of the 2 terms in the binomial. So we could say we have 2 times a number times x would be equal to 18x, our middle term in our binomial. 2 times a number we don't know times x gets me 18x. So that means if I were to divide by 2, I could get 9x is equal to whatever this number times x is. So 9 is our missing number. So she said the second term is twice the product of the 2 terms in the binomial. We had the initial term being x, and our other term is 9, so we can add 9 into this. So we could essentially say x plus 9 times x plus 9 is our binomial, but we should maybe check our work with this third step. It says the third term is the square of the second term. So if we look at 81, that needs to be our term that we don't know squared. If we were to take the square root of 81, take the square root of both sides, we get 9 would be equal to that term we didn't know. So we can say our final answer is x plus 9 times x plus 9. Simple as that. And that will get us exactly what we have here up at the top of our screen. So now what we're going to do, I'm going to delete a little bit. So now what we are going to do is also try this with another number. We know that this ended up getting us x plus 9 times x plus 9, or x plus 9 squared. Now let's see what we can get for this other quadratic equation. So again, it has 3 terms. Awesome. That helps us out. The first term is the square of the first term of our huge binomial, or our binomial. So x squared is equal to x times x. So that means if we were to rewrite our binomial, we could say that the first term in there is going to be x times x. So x is going to be at the front of both of them. Our next term, our second term, it says our second term is twice the product of the 2 terms of the binomial. So we have negative 10. Negative 10x is equal to 2 times a number we don't know times x. So 2 times the number we don't know, we could also divide by 2, so we get negative 5 over here. So negative 5x is equal to a number we don't know times x, or negative 5. So right now I'm going to put negative 5 into my equation, and we're now going to see if this third term is this, if it's the square of that binomial, then we're all set. So 25 is equal to the number we don't know squared. Well, so that number we don't know, we just need to take the square root of both sides. So we'd get 5 is equal to the number we don't know. But we also know that a number squared could be negative. So we could say negative 5 times a negative 5 could also give me a 25. So I had two options with this one, and the negative 5 works with my equation. So kind of played around with factoring a perfect, what's called a perfect square binomial. So these situations are called perfect square binomials. They are essentially a situation where we're going to have the same thing multiplied by itself each time. So we had x plus a negative 5 times x plus a negative 5. Okay, so we've worked ourselves through two factorings of perfect square binomials, and now let's see a problem that's more complicated. Ooh, I should go back just one second. So our answer would simply be this. You're going to want to know that, how to be able to write your answer to a factoring of that. So this is equal to that. So now let's go to something more complicated. So if we had something more complicated, we need to think about this in a slightly different way. We need to essentially find a number or two numbers that can multiply here but add here. And so two numbers that will multiply to be one number, 24, but add to be 10. So a lot of the times when I do this sort of thing, I'm instantly starting to think of factors of 24. And if I were to do that, factors of 24 are 1 and 24, 2 and 12, and I'm thinking factor pairs, numbers that multiply. So 2 and 12, 3 and 8, 4 and 6. So dealing with those numbers, I'm looking for numbers that will multiply to be 24, but if they were added together, they give me 10. So first things first, we need to talk about that first term again. Our first term is going to be the square of that huge binomial of that first binomial. So x squared, we would break that down into x times x. So we know that our first term would be x times x. Our second term is going to be the sum of two terms in the binomial. So essentially we need to take that 24 and figure out what of these multiples would get me 10. We know 10 could be 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, 4 plus 6, or 5 plus 5. Since 4 plus 6 is also a multiple of 24, that seems like a pretty good shot. So our next term would be 4 plus 6, and we still have that x added in there, so it'd be 10x. So we could try 4 and 6. Now our last step is to see if that 4 and that 6 truly work. So our third term needs to be the second term of, taking that third term of that binomial, we should say third term, and actually doing the math. So 4 times 6 equals 24. So our finished factored form is x plus 4 times x plus 6. So we could even check our work with this and say x plus 4 times x plus 6 equals x times x is x squared. And so we're doing FOIL. X times 6 is 6x. 4 times x is 4x. And 4 times 6 is 24. So we can finish this up and say x squared plus 10x plus 24 after combining like terms. So we know that our original expanded form of our equation, this x squared plus 10x plus 24, is the same as our expanded form, or as our factored form, x plus 4 times x plus 6. I would like you to also potentially watch a video that is up on our class website and in the YouTube playlist for Math 8. And its title has something to do with the bottoms up method. Quite literally bottom, B-O-T-T-O-M, S, up. So if you were to watch that video, that gives you sort of another tool for factoring quadratic expressions if this didn't make complete sense. I would suggest watching both of them, enjoying them, have fun, and try your hand at the homework. Bye, guys.